whatever I'm teaching you is for IIT, NEST and the JEE main or advanced. Whenever we are talking about electron affinity, that means single gaseous atom, an isolated gaseous atom, will be accepting an electron. So what is happening with a molecule? We need the isolated atom. So if it is H2, okay, let's call it halide, which means F2Cl2Br2. Then we have to dissociate the molecule first. Okay. Then we are getting this two individual atoms of the halogen. Then if we are adding two electrons, which is what? First electron affinity. That is why it is said to be as EA1. Then we should be getting what? 2x minus the 2 is missing over here. Okay. And this is the simple definition that you can see over here. For chlorine atom, you can see the electronic configuration, which is like simple plus 10 stuff. We say 2, that is for the couplet, then the octet, then the electrons for like that. So it is having a valency of 7. If you add one more electron, then it is gaining 1 electron. This is the chloride ion, and that is the electronic configuration, which is almost isoelectronic with the next movable gas, which is Rb. Now, while the electron is being added, it's becoming a more stable thing, so energy is released. And that's why we're calling this to be as an exothermic process. Okay. If we take oxygen, we take out one electron, it becomes a plus. Okay. Anytime we are doing an electron withdrawal from the valence cell, then it is a energy taking process by the system, so it is a endothermic process, so to say. And if you do the reverse of it, then we're going from O plus to oxygen, so that is electron affinity of O plus cation. Okay. We can do a similar example of fluorine isolated atom, added becomes fluoride, again becomes octet, so this is again a exothermic process. If we do the reverse, that's an endothermic process. Now, mostly we are never talking about the temperature at which this is happening. So what we are saying in advanced books that we find that this is happening at absolute zero. So the electron gain enthalpy will be written using from brackets. And this is the equation that we use. Is it clear? So what you are thinking to be as electron affinity is something very similar to electron gain enthalpy. Okay, this Eg means in the suffix means electron gain enthalpy, H is enthalpy, is related to electron affinity, and then there is something R, which is the universal gas constant, and there is the temperature. And we have already said this is taking place at what? Absolute zero. So now, standard question that comes in related to classical questions or GMA or maybe in the first semester of a BSc or the BTech is if you want add one electron to oxygen, this is the electron affinity. But when we are trying to add one more electron, that is making it O2 minus, which is oxide ion, Second time, when you're adding the electron to already negatively charged species, it is not exothermic, it is endothermic. That is the point to be taken. Okay? And then if you add these two energies, then what is will happen? What we find? To calculate this is not negative. Right? So what are the questions that in a statement they ask? First electron affinity is exothermic because of attraction between the nucleus of the oxygen and electron. Second is endothermic. Why? To overcome the repulsion force between already something which is aligned and another electron entering. So whenever you are trying to put in an electron inside O minus or N minus or N2 minus, right? The successive electron affinities, they are not going to be exothermic, but they will be endothermic in nature. Okay? Now we have over here something which is the entire formation of magnesium toluene in presence of oxygen forming MgO. What is this diagram? This is, as you see, this is using Hess's law. What is happening first? Heat of atomization, that means solid to gaseous magnesium. Then we are going for successive ionization energies. The first one, second one, and we already know by now that if you're trying to take out an electron from already a positively charged cation, then we need more energy. So successive electron affinities are always higher. Okay, so E1 or IE1 will be less than that of IE2. Alright, and here we have EA1, but the next one is, this is exothermic, this one is endothermic, right? And yet, if you look at the calculation, yet we are forming this MgO. Why? Because when these things combine to form magnesium oxide, a huge amount of energy is released as the lattice energy, that is formation of 1 mole of magnesium oxide, collection of this. Okay, so this energy is overcoming all this to result in the formation of this. Understood? So principally, some of these individual processes may be endothermic, okay, but when they co-join, this one and that one co-joins, the cation and anion, and 1 mole of it combines, then 1 mole of this lattice energy is released. Okay, that itself is so exothermic that this allows the entire thing to happen. Okay. Otherwise, this would have not happened. So whenever atoms or molecules are combining, in most cases, the process is exothermic. In some cases, it could be endothermic. Right? That means what? That individual atoms are moving from a less stable state to a more stable state. That's why the reaction is happening. So that is what bonding is all about. In some cases, if you are trying to go for the nitrogen cycle, whenever this electric spark happens, the nitrogen combines with the oxygen to form 2NO. Happens during the lightning. That NO is formed inside the air, which again combines with the oxygen to form NO2. Right? When NO2 dissolves in water, it forms, importantly, two kinds of acids, which is nitric acid and another is nitrous acid. So that also is a question that is asked in the exams. Okay. Is that clear? And when it happens more and more, then whatever the raindrops that you're getting, those are forming acid rain. So that's how the nitrogen from the air enters as a nitrite or a nitrate inside the soil. Okay. Somehow you've got a picture. So that is one way of converting nitrogen into nitrite or nitrate. Okay. So if you have that kind of a rain drop collecting over dolomite, what is dolomite? Magnesium carbonate and calcium carbonate. It would be forming what? Magnesium nitrate or nitrite or calcium carbonate or calcium nitrate. If it is limestone, then that's CaCO3, which is in the chalk. নিউজ ওরা শুনতে পারলো যে প্রচন্ড অ্যাক্সিডেন্ট হওয়ার জন্য তাজমহল ডিস্ট্রয় হচ্ছে, right? The walls are colluding. তার মানেটা আর এই পলিউশনটা কি? মানে there are, if we have a lot of factories, right, which are liberating gases like NO2, okay, or sulfur dioxide or peroxide. Okay, they are called generation of acidic oxides from factories by human beings. So those are in a sum up called liberation of acidic oxides by anthropological sources. That means we human beings are liberating these kind of acidic acids in a certain manner. It is not happening through some volcanic eruption or something like that. Okay. If you're doing it from factories, then it is we the human beings we are doing it. So that is not something part of the natural process. When it is not part of the natural process, we are calling it to be as anthropological gases being liberated in certain manner. Alright? But if there is a volcanic eruption, during volcanic eruption, a lot of sulfur deposits happen, magma comes out, sulfur comes out, a lot of kind of ores come out, and then if the sulfur catches fire, then that is true. Some natural source, SO2 and everything is getting inside the environment. Okay, we have this. We hear a ring of pearls and ring of diamonds and all these kind of things, which they are tectonic movements, and in Philippines or Jakarta or this kind of islands, right? The northeast islands going towards Australia. Okay, these kind of eruptions are happening. Okay, understood? And what about the carbon cycle? So because we have a lot of power stations in which we are burning carbon, okay, from the electric power, and that is, if you go for the complete oxidation of the carbon, then it becomes CO2, and we know that is a greenhouse gas, right? I think this is the temperature of the, because carbon dioxide is heavy, right? Even sulfur dioxide is heavy, sulfur dioxide is heavy. So when they have this property of absorbing heat from the sun, right? They have this property of heat absorption, right? So they are absorbing heat. If they do not absorb the heat, then we will be a cold planet. So whenever we maintain the balance, then it is a habitable environment. Whenever we are not maintaining the balance, then we become non-habitable, right? Understood? Because in addition to this, I've discussed why the waves help us, to dissolve the carbon dioxide inside the sea, because they bring up the phytoplankton, right, from the sea, and that absorbs the carbon dioxide, during photosynthesis. Okay, so this thing is happening, like again, multiple things are happening within the earth to keep up a balance. Right? Whenever we disturb a balance, then we are making the earth inhabitable in some sense. Okay.